Here's a graph you should recognise. It's y equals x squared. This is the graph of y equals minus x squared, and you can see that the graph is just a reflection of y equals x squared. Here's the graph of y equals x minus 2, x minus 3. You can see that these points here are x equals 2, y equals 0, and x equals 3, y equals 0. When y equals 0 from this equation, you get x minus 2 bracket x minus 3 equals 0. The solution of those equations is x equals 2 or x equals 3. So that's why the graph crosses at x equals 2 and x equals 3. Here we've got a similar graph, but this time it's x minus 2 and it's 3 minus x. Now if you were to multiply out x minus 2 times 3 minus x, we'd have 3x, we'd have plus 2x, we'd have minus 6, and we'd have minus x squared. The fact that it's a minus x squared graph means that the graph is this shape. When it's a plus x squared graph, it's this shape. But it's the same points on the x-axis as before. When x minus 2 equals 0 and 3 minus x equals 0, we get the intercepts on the x-axis. Here we've got y equals x minus 2 squared. If you solve that equation, x minus 2 squared equals 0, you simply get one answer, x equals 2. It's what's called a repeated root because the x minus 2 is squared. And when you get a repeated root, at this point the graph just touches the x-axis. It's called a tangent to the x-axis. So when you've got an x minus 2 squared, it's a tangent to the axis. Now we're getting into x cubed, and this is the graph of y equals x cubed. And here's the graph of y equals minus x cubed. As before, it's a reflection in the x-axis. So this looks a little bit like y equals x cubed, which was this shape, but it's reflected in the x-axis to get y equals minus x cubed. So now we've got y equals x minus 1, x minus 2, x minus 3. The x values that make y equal to 0 are x equals 1, x equals 2, and x equals 3. And they are the solutions of that equation, 1, 2 or 3. If you put 1, 2 or 3 into there or there or there, the whole lot will be 0, y will be equal to 0. So at these points here, the y value is 0. Here we've got a very similar equation to what we had before, but this time it's 3 minus x. Now if you were to expand these brackets, which I'm not going to go to in the full way, it's x times minus x. The x cubed would be minus x cubed, so that's why it looks like the minus x cubed graph. If it was plus x cubed, it's generally this shape. If it's minus x cubed, it's generally that shape. In this graph you can see we've got two minuses, 2 minus x and 3 minus x. So this time the 2 minuses cancel out and we get the normal x cubed shape, which is this type of shape. Here we've got x minus 1 squared, so as before the x minus 1 is a repeated root of the equation, so at this point here the graph just touches the x-axis at x equals 1. But this one is a normal x equals 3, so that's x equals 3 at that point and x equals 1 at those points. And now we've got x minus 1 cubed, so there's a repeated root, it's 3 times, so there's only one solution when x to make y equal to 0, and that's when x equals 1. It's an x cubed graph, so it's generally that sort of shape, so that means we get one repeated root and it's a tangent at this point here. Let's think how we might go sketching this graph of the equation, the graph of this equation here. If you look at the equation, then x is a factor, so we've got x squared plus x minus 2. If x is a factor, then we're just left with a quadratic. That's got to be 2 and 1, it's got to be plus 2 and it's got to be minus 1. So we've now got y equals x, x plus 2, x minus 1. So that means it's a cubic, it's a positive cubic, it's generally that shape, and it crosses at x equals 0, at x equals minus 2, and x equals 1. And there it is. There's x equals 1, there's x equals minus 2, and there's x equals 0.